I'm going to stop talking to myself about the microphone, talk to you now. Good morning. I am Susan. Oh, that's very exciting that worked. I'm going to be talking to you about scraping some of the New York Public Library catalog, a story of Requests and BeautifulSoup. In short, this is an introductory talk about web scraping in Python. So I assume that because you're here, you've written some lines of Python before. I don't assume too much more of a programming background than that. And I also assume that because you're here, you want to learn something about web scraping or you want to explore web scraping further. If you happen to be an expert on web scraping and are not up for a novice level talk on web scraping right now, it's okay if you want to go to a different talk. I won't be sad, and maybe you can trade places with someone who's really excited about web scraping there. Also, despite cautionary tales, this is an interactive talk. Some of you have your computers out. If you have one hiding away, you might want to take it out. We'll be using it later. And if you don't have pip on your computer, you're probably going to want it, or you're going to want to make a friend who has it. So I'll give you a couple of minutes to rearrange if you don't have a computer with you, or to get your computers out. We won't need it. So we're going to start by talking a little bit about what web scraping is. And I'm going to use this project that I did with the New York Public Library catalog as a lens. But it's generally a conceptual talk. We'll talk a little bit about why I wanted to do it through this project, how you can scrape websites in Python, and how to handle the data that you get once you've scraped it, because it can be kind of a mess. And as I mentioned, it's hands-on, so you'll get a chance to do some requests in Python and scrape a website on your own. This talk includes a total of 0 things that I knew a year ago, and this should be really encouraging because everything is learnable, everything is accessible, and maybe next year you can give this talk. So in short, web scraping is data extraction. So you're taking information from a website. You want to get the content that's actually there, not necessarily the content that you hope is there. You're dealing with the reality of the world. And it's pretty exciting because it means that you can access any data that's on the internet. And you don't need the owners of the website to partner with you in getting that data necessarily. Also, I'll note that it's not the same as just looking at a website, and it's not the same as getting screenshots from a website. I mentioned this because this is something that I considered when I was trying to get this information for the project that I'm going to tell you about. And so I guess we need a bit of a better definition. So let's say that scraping is accessing the HTML content of a web page. As I mentioned, I'm going to use Python to talk about this, and I'm specifically going to talk about it through the lens of getting the information from the New York Public Library catalog to create a little book mapping web app. And I think that's useful because you'll get a feel for some of the difficulties that I encountered and kind of get a feel for some reasons why you might want to use it or might want to use some of the tools that I use. But it is a broad talk, and I hope that you'll use these concepts for other uses, and you can also use them for other languages. Python is great for it, but there are lots of other options. The project that I'm going to talk about was made at the Requests Center. If you're not familiar with it, I definitely encourage you to check it out. It's a 3-month writers retreat for programmers. And one of the things that I wanted to do while I was there was make some projects that talk to other things. So I was great at writing code that stayed on my computer, but I was interested in things that interfaced with the web or pulled from other programs using different libraries, etc. But at the time I was a little bit distracted, and the Hunger Games movie was about to come out, and I really wanted to read the Hunger Games book, the last Hunger Games book, before this movie came out. So I was sitting there at the Requests Center, going back and forth to the New York Public Library catalog. I typed in Mockingjay as the title, as you might expect, and got something like this, which is a list of books, a list of copies of the Mockingjay paperback book. And I was at the Recurse Center, so I wanted specifically copies that were close to where I was. And this list is pretty useful if you're, say, at 96th Street and you would like to go to the 96th Street library. It's not that useful when your library has a name like George, or St. Agnes, or Chatham Square, or Aguilar. These aren't that informative names. So what I was doing was I was starting at the top of the list, copying and pasting that library name into Google Maps, seeing if it was close to the Recurse Center, and if it was, I'd write it down, and if it wasn't, I'd move on. This is highly inefficient for the program that is my brain. And I figured there must be some map of all of the libraries around, and that actually does exist. And that made my life a little bit easier, so I could select the libraries that were close to where I was, and then check them against that list of available copies. It's still not ideal. What I really wanted was to be able to filter that map based on what was available. Like, I wanted to only see the pins that had my book available. And behold, here was my project that involved things talking to other things. My program specifically talking to the library catalog. So I was in a position where I needed to figure out how to get the information that was on the catalog on the web into my program. And here was where I went down the screenshotting rabbit hole, and I thought maybe, by force of will, I could get this catalog into my program. And, clearly this is not the best idea, but I did need them to talk to each other. Then it occurred to me that the catalog is just a program. So it's another piece of code. And so the issue isn't really about getting what I see on my browser into the code. It's an issue of getting the code that constitutes the library catalog to talk to my program. I had heard vaguely about this thing called an API, and I did some Googling. I'll give you a little caveat. APIs are complicated. There's a lot to be said about them, and there are lots of nuances about how to make them and how to use them. And I think there's actually another talk today about that. You can definitely take a look. There's a lot of resources on the internet. But for our purposes, an API is a set of rules that determines how one piece of software talks to another. So it allows my program, a program, to talk to another program, in this case, something that's on the internet. Normally you would, or many APIs involve getting an API key. So you can sign up or contact the person who manages the API. You say, I'd like this unique key to give me access. And that's pretty useful for them, because if you're exhibiting reckless behavior around the API, you're sending zillions of requests and you're causing unnecessary traffic, they can shut you down pretty easily. They can just inactivate your key. And it also can give you some reassurance. If you're offered a key, it's probably fairly well maintained. It probably works. So I decided to send a nice letter to the New York Public Library asking for an API key for their library catalog. I'll also note that they have another API that's for their digital collection. So you can look at the images that they have scanned in. It's pretty cool. But for this case, I needed the catalog. And they sent me a nice letter back saying no. Actually, what they said was, are you an employee of the library? If you're not an employee of the library, then no. So I did think about lying and telling them I was. And I also thought about maybe borrowing access from someone who already had access, but I decided that that wasn't a great idea. So I nixed the idea of being able to use their API, which led me to web scraping. As I mentioned before, you don't need their partnership to scrape a website, because the information is available to you. In the same way that you can direct your browser to a site, you can direct your program to a site. And as I mentioned before, it's not really directing it to what you see, it's directing it to the HTML content. So for that, I needed to be able to view the HTML content on that page. or inspect the HTML content on that page. And thankfully, browsers are pretty useful for that. I like the word inspector. I think it's great. Sometimes browsers call them developer tools. It might be called your web inspector. And here in Firefox, you can see how I got there. So it's under the tools menu. Then you can see web inspector, web developer, sorry, and then inspector is one of the options. So when I hit that inspector tab, a box pops up at the bottom of my screen, and inside that box is HTML. And what's really cool about that is that I can mouse over that box to different parts of the HTML, and it'll highlight those sections on the web page, and vice versa. So I can mouse over the sections of the web page that I'm particularly interested in. You know, in this case, if you're picturing the results of the query search that I had before, I might mouse over the list of libraries to get them into my program. And then it'll direct me to the HTML that is relevant to that. So if you haven't already, I wanted to give you a chance to inspect some web pages. So definitely, if you don't have a computer, find a friend, pick a site, and inspect. And if you're interested in following along with the example that I provided before, there's a link to the list of available copies of the. Okay. All right. Now that hopefully we're convinced that you can access the HTML on a page, you have to figure out how to get that into the code. So you probably know from the typical interview question what happens when you direct your browser at a web page. What happens? Name something that happens. HTTP. Yeah, an HTTP request is made. So what I really want is for my program to make a request. There are a lot of ways to do this in Python. I used the requests module. There is URL lib, URL lib2, HTTP lib. I thought the requests syntax was pretty simple, and I liked that it sounded like English. So that was the choice that I made. But all of those are valid options, and you can definitely take a look at your options and choose what works for you. If I want to get the content of a web page, what request would I make? Yes, I would make a GET request. So the syntax for that is, I set my variable to request.get, and then the URL in quotes. And when I type print r, what do you think the value of that variable is? That's a good guess. What do you think is inside there? Also a good guess. Does anyone else have a guess? Sorry? The body of the whole page. Headers, whole body. Object. Is everything between the URL tags? So maybe I should specify my question further. So you guys have a lot of information about what's inside that object, but what is the string of it? What happens when I print it? Do you think that the whole web page content comes out? That is definitely what I thought would happen.
It's a request object, right?
It is a request object, and the string of it is actually the response code. So the request is made. I say, hello, are you there, website? And it's like, yep, I'm there. Sometimes it's like, no, I'm not there. But in this case, it says it's there. So in order to actually get those things that you were mentioning, in order to get the whole body of the site, you need to specify further. So in order to get the whole thing, you do r.content. And then there are other methods. There are other methods you can call to get further in. And I encourage you to play around with those. So if you don't have requests yet, I encourage you to install it, pip install request. Also, there are still people who don't have access to a computer, so feel free to rearrange and get to know people. This person looks very friendly. This person looks very friendly. They all have computers. And then open up your terminal, type in Python to work in your REPL. Again, I'm sure you all know this, but super simple. Your REPL is your interactive Python interpreter. So it reads the code that you write. When you type in Python, a little command prompt comes out. You type in some code. It evaluates that code. And then it prints out the result of what was evaluated. And then it loops again. So that's what the REPL is and what it stands for. And especially if you have an interactive REPL like IPython or VPython, it's a great place to play around with new modules of code because you can see what options are available to you. And there's tab completion, and you can put in that response object, and it'll let you know how to get the headers of it. It'll let you know how to get the content of it. It'll let you know how to get the body of it. So, yes?
Is requests the main module you use? You spoke about an earlier one.
Yes, there's
HTTP something.
HTTP lib, lib, and then also URL lib 2.
Do you import all that as part of requests or separate client?
I think requests actually uses URL lib 2 as a dependency, but URL lib 3. Thanks for that. But you won't need to import it separately. And again, this is the link to the site that I used. If you want to write it down, because I'm going to back up so that you can see the syntax. So I'll give you a chance to play around with that, and definitely poke around and see what other parts of the site you're able to access. Also, you can request from a site that has a login too, which is pretty useful. So say I want my own GitHub, I can put in my username and password as part of that request. You should check out the docs for how to do that, but it's just authorization, username and password. Hello. Does anyone want to tell me what you found, what you're seeing? Seeing HTML. That's great. That's what I found too when I printed our .content. And I was working on this site. That's the link that I gave you to follow. And not only did I get HTML, I got the same HTML as I saw when I inspected it with the inspector, which is great. So I, like you, typed in Python, and the REPL opened up. It said import requests to use requests. And then I typed in r equals request.get and then the URL of that. I gave you the bit.ly link, the short one, but this is the full link to that particular page. And printed R, says OK. And I printed out the content and got something like this, which is really horrible. And it goes on for 791 more lines. And the worst part about this is what do you think the type of this thing is? What is the type of the content?
String.
Yeah, it's a string, which is pretty horrendous because there's a particular bit of information that I want to get from it, namely the name of the library, and there's this 791 line string.
Is there a max for that string then?
Ooh, that's a good question. I don't know. So I had this mess of string, and I was wondering how to parse it. I started splitting it. I started doing terrible regular expressions on it. I hear this is a well-trodden path. I've trodden it. You don't have to do it now. If you would like to go down that rabbit hole a little bit, you can. It'll show you exactly how complicated the problem is, which is pretty valuable. But if you keep in mind that HTML is like a data structure, then it helps to realize that if you can just restructure that back into HTML, it'll be a lot easier to handle. So just stepping back for a minute, generally if you're about to bang your head against a problem that seems like it should be easy, but seems horrible, it might actually be easy. And it might actually be easy because someone else has probably attempted to solve it before, and you can take their stuff and use it. And that's the case with this. So not only Are there parsers available that other people have made? There are parsers available through Python itself. Just a word about HTML. It has tags, and it generally has paired tags. So it'll start HTML and end HTML, you know, start a header and end a header. And that gives it kind of a nested structure and a hierarchy. And the more you learn about HTML, and here's where your inspector is awesome again, because you can look at the HTML and you can read it. And also the more you write HTML, the easier it is to know how to go in and parse it. But basically that brief bit of information about the nested structure is all you need to know to start diving in. Conveniently, Python's HTML parser is called HTML parser, or HTML.parser. It also has LXML, it's another option. I ended up using BeautifulSoup, which is a library intended for scraping. There are a couple reasons why I used it. I thought the documentation was really good. I guess a pretty good reason. Also, HTML parsers expect HTML, and they expect HTML that works. So having BeautifulSoup, which is intended to deal with the state of the world as it is, which is sometimes imperfect, is pretty helpful. It doesn't die as easily when you get bad HTML. So if you look back at this list of libraries, what I wanted to access was the name of the library. And you can see there are lots of names, but I'm going to just direct you to the HTML that's pertinent to that first item. So it's as if I were using the inspector and I kind of moused over that row. This is the HTML that I would find. And I use BeautifulSoup to direct to that section in the first place, but just for simplicity's sake. You can see we have this row of HTML that contains the name of the library that I'm interested in. And it's inside this set of TD tags, so table data. It was in a larger table that you could see, and then this is a specific set of data inside that row. And this section is nested inside these TR tags. So these are the table rows, and then inside there are different items of data. So in order to access something within a section, I first need to get into the outer section that's nesting it. So I'll show you how to do that using BeautifulSoup. I'm using BeautifulSoup 4. It works with Python 2.7 and Python 3. And when you give it the content of your request, it'll give you back an object that shares the HTML structure of the original content that you gave it. So in short, it parses the string of messiness into something that has the HTML nested structure based on the tags that it finds. There are some tags that have methods associated with them with BeautifulSoup. You can poke around in your REPL to see which ones those are. TR isn't one of them, so we can use the find or find all method to do it. So import BeautifulSoup, create a BeautifulSoup object from the content of the request, and then find that table row using soup.find. Yeah, I'll leave that alone. So now we've gotten back the section that pertains to that whole row, and it has information that you're not interested in. It has the section of the library that it's in, and it has the call number, and it has whether it's available, but you know it's available because it's in the available table already. So now we need to direct to this particular part. So we're going to use the same type of thing again. We found that chunk, and now we want to hone in on that particular piece of data. So now we go in and we use find again. And if you look back, this is specified by this item branch name. So there are lots of table data sections in here, but what's unique about this one is that it has this item branch name in it. Test ID equals item branch name. So whereas before we were able to search by tag, now we're going to search by the attribute that's provided. A note, this result of find is a row object, so you need to actually get the contents out of it. And to do that, you use .text. And what comes out is 115th Street with a ton of spaces that you can then strip and deal with as you would like. So maybe you want to capitalize, or now you can do your string formatting on the actual information that you're interested in instead of on this huge thing of terrible HTML. This works differently if the content that you're looking for is determined by JavaScript, and there are other tools that you can use for that. And again, a note that Python is really cool, but it's not necessarily special. So a lot of languages give you the capabilities that I described here, and they also have libraries to do a lot of the same things. But now that you have the scaffolding, you're able to get web data in the language of your choice. So ultimately, I did end up with a book mapping app, and it filters by actual availability. You can check it out on GitHub. My handle is SusanMotion. And give you an opportunity to ask any questions.
If a page has multiple sub-like pages, so all these books on one page, but what if the catalog has multiple pages? Do you then make the call again with a counter to the page?
I think I know what you're asking. So when I make a search for a book, a bunch of different copies come up. So I have like a hardcover book and a paperback book, and each of them comes up with a page of availabilities.
Or even if you do a search, but first the page, the web page displays, say there's 100 results, the page displays 1 of 10, page 2 is 20 to 20.
Right.
So, but you got to...
That's actually one of the issues with scraping. So what I did to get around that is that the next link that you select in order to get more is in and of itself a link, and it has content associated with it. So I did request both of those things.
So you make multiple calls.
Yeah.
And iterate through the results.
Yeah. And that's not something that I would have had to do if I had access to the API, because I would be able to specify how many results I wanted back right away.
So did you literally go to the public library page and search for the book and then copy the URL as you requested every time?
No, so I used, I offer the user different parameters that they can put in the same way that the site offers the user parameters that they can put in. So you can put in a keyword or a title or an author. And if you notice when you type those things in, they appear in the URL. So that's part of the request that's sent to the site. So basically, I created a URL that had those parameters from the user and used that to request the specific results of the site. Does that make sense? Any other questions?
If a page requires you to log in to authentication, does that, I guess that information is passed once the first time in, and then somehow your application has to store that.
Right. Each time you make a request, you will need to provide that authentication. Like if you if it's a login page, if you go back and do it later that day, you still need to provide that. But similarly, you can pass it as a parameter in. So you can ask, you can either provide your own login, like say I want to make a program that always accesses my own GitHub. I can pass those in, or I can give a user the opportunity to put those in. Have other questions? Yes.
Do you ever do XML parsing with BeautifulSoup? And if so, like, do you think, what are the advantages over using LXML?
So you definitely can. I shied away from using LXML because of the syntax. Like, I'm just not as familiar with the XPath stuff. But you definitely can, and I think both libraries are pretty good and pretty valid, except that BeautifulSoup like has very nice documentation, and like hopefully won't die if there is badness on the site. Anyone else? Yes.
Can you talk about some of the tools used to scrape sites generated using JavaScript?
I'm not too much of an expert at this, but I was looking earlier. There are a couple of libraries that you can find. So like BeautifulSoup is pretty good at directing you if it like can't do everything for you. So I actually recommend that you use their documentation to follow through. And it's like, oh, if we fail here, like you can use these other libraries. Good. Anyone else? Thanks.
Actually,
Oh.
I'd like to point out one thing. I did use requests
Yeah.
to pull scripts on websites.
Sure.
If you need to use cookies for the website to work properly, you have to use session. It's also part of requests. So instead of just creating one request, you create a session and then you do session.request and then it's all exactly the same as that. But a lot of times, if you put in a request on a site that requires cookies, you get back nothing. String, the response to the entity, and if you just create a session and then do session.request, you'll get back the forays.
Cool. Thank you. Great. Thanks a lot.